Hello everyone and welcome back to my channel. In this video I'm going to talk about finding the minimum spanning tree using the Kruskal algorithm. So here's an example of a graph G with 6 vertices or 6 nodes and some edges. As we know, a minimum spanning tree of an undirected weighted graph is a subgraph of the graph G in which there is no cycle and the number of edges is equal to number of vertices minus 1. So we're assuming that the graph is connected. So there is a path from a node to every other node in the tree that we have. So the Kruskal algorithm is also a greedy algorithm similar to the Prim's algorithm. You can watch my other video in which I have talked about and I've explained the Kruskal algorithm for the same example. So how it works, it is greedy and it chooses the edge or edges with the minimum weight. So here we have 6 vertices. So as you see, I put them in 6 like the independent lone islands. So that's why I explain all the time that assume that these nodes are in different islands, and we're gonna like to create a path or like put them in one single like the island, or connect these islands together. So here is our minimum spanning tree so far. As you see, there is no edge yet, but we're going to add this one. So we're going to start with the edge which is minimum. So one thing that we need to remember is that we need to sort all the edges before starting the solving the Kruskal algorithm. So as you see here, if I want to sort in this graph, it's easy to do that because there's not too many edges. The very first one is the edge A and H with the cost of 1. The next one is the C and F with the cost of 2. And then the next one is DH with the cost of 4. And then we have AC with the cost of 5. And then we have CD with the cost of 6. And the next one is AB with the cost of 7. And we have F and D with the cost of 8. And finally we have the B and F with the cost of 9. So we need to just sort all the like the edges at first based on the weights. And we're going to start with the first node which has the minimum cost and has not been added to the tree yet. So here, as you see, the edge A and H tries to connect the vertices A and H, and so far A and H, both of them are in different islands or different sets. So it's easy to add them, add these edge actually to the minimum spanning tree. So here I'm going to add A and H with the cost of 1. So check means that we're done with this edge. Next one in the tree, in the graph, is the CF, and as you see here, C and F are different islands. So one thing I forgot before I'll continue talking about the next edge, when we're adding the like any edge, like here A and H, we need to connect A and H together. Means that they're gonna go to the one island together. So here A and H will join each other and go to one island, A and H. Next one is C and F, which are, as you see here, in 2 different islands. So we should be able to add the CF here with the cost of 2, and that means again we need just to merge these 2 islands and create one new island in which the C and F are together here. So C and F. Now we have 4 islands. So the next one, the next edge is the edge DH, and as you see here, D is in this island and H is with the vertex A. So it's fine to add H and D with the cost of 4 to the spanning tree. So here let me just add D to this graph. So A, D and H now are connected to each other, and now we have B and C and F in other islands or sets. The next one was A and C with the cost of 5, and as you see here, A is in this island and C is in this island, so there's no problem. So we can add A and C with the cost of 5 to this island, and that means that we need to merge these two islands together. Remember that when we were merging these two, you need to merge all these, or take all the other ones. So here are going to be everything except B, so it's going to be C and F, and we have only node B, and that's, as you see, that's what we see in the minimum spanning tree so far. B is a standalone, and all our nodes are connected to each other. So then next one is then like the C and D, so that we can connect to each other. However, C and D already are in one island, so we cannot add this one. And the reason that we cannot add, assuming that we can add it, if we add this edge C and D with the cost of 6, we're gonna have a cycle. You see that the D to H, and here this actually creates a cycle which we don't want to have. So that means that, again, if they are in one island, or if they are already have merged, then we cannot add them together. So we cannot add this edge. So let's go to the next one. That we just red mark here, and then A, B, and here A and B is fine because A is in this island and B is in this island. So we're going to add A, B with the cost of 7, and now we created one giant island, or we actually connected all the islands together, and these nodes are going to live together happily ever after. So, and here we're done, so we don't need to even to check and bother to see that if we can add any other edge to the spanning tree or not. It's obvious that F and D cannot be added for sure. If you're going to try to F and D, is going to create another cycle. B and F also will going to create another cycle in the graph, and that means that we're done. So that's how the Kruskal algorithm works. It's a greedy algorithm that sorts all the edges based on the weight first, and then it works by choosing the edges that that are not connect or not creating a cycle. So you can again watch my other video about like the minimum spanning trees, also my like the whole day playlist about the graphs. And if you have any question, please add it in the comment section. I will be happy to answer your questions.